Well, if we look a little further here, we can see that this particular parabola's x-intercept would be the point we've already found. Its x-intercept happens to be its vertex. That doesn't always happen. It did happen to happen this way in this problem. So here we could say that the y-intercept was 0, 9. The x-intercept would be the point -3, 0. Something else that we often talk about when we talk about quadratic functions is we talk about the quadratic function's domain and range and the intervals of x across which the function is increasing or decreasing. Well, a quadratic function such as this has no problem areas for x. Problem areas, I mean things like taking the square root of a value, and if we're in the real numbers, we can't take the square root of a negative. Or a problem area like a fraction where the variable's in the denominator, we can't allow that denominator to become 0. And that would put restrictions on the x values that we could put into the function. Well, this quadratic function has no such restrictions, so the domain of this quadratic function is all real numbers. There's no restriction on what we can put in for x. If we think about the range of that quadratic function, the range is the y values. Well, if you look at this, there are no y values in this function below 0, are there? Does the function's curve ever get below the x-axis? It doesn't. So the function's value is never below 0. But it continues on as high, as large in the y as we would want to go. In other words, it goes up to positive infinity for the y's, and the very lowest y value is here where y is 0. So the range is an interval of 0 to positive infinity. And actually, the 0 value is there in the range, so if I'm going to use this interval notation, I should make that a square bracket to show that 0 is part of the range. Well, one of the other things we talk about is where is the function increasing or where is the function decreasing? Across what intervals of x? Well, if you think about it, as we move from left to right on the x, as we come from negative infinity on the x values, aren't the function values coming down as we come from negative infinity on the x? So that would be where the function values are decreasing. The function values are decreasing on the interval of x's from negative infinity to -3. The function's getting less and less and less and less, and then it turns at -3, and as we continue on with x's that increase out to positive infinity, as the x's increase from -3 to positive infinity, the function's values are going up towards positive infinity. So across these intervals of x, across this interval from -3 to infinity for the x's, the function's going up. From negative infinity to -3, the function is coming down. And remember, when you're talking about intervals of increasing and decreasing of the function, you're always talking about the x values. And across those values of x, what is the function doing? Across the values of x from negative infinity to -3, the function's coming down. And across the interval of x's from -3 to positive infinity, the function's going up. And that's what we always view increasing and decreasing in terms of the intervals of x. So here's a process we can go through to graph the quadratic function and learn quite a bit of information about that function from its graph.